Hello everyone, I am Shravya. I am going to present my internship project on embedded systems. The focus of my project is a washing machine system. In this project, I built a virtual model of washing machine using PIC microcontroller and software tools. My goal was to simulate wash cycles like wash, rinse, spin, and dry. For this project, I used PIC16F877A microcontroller, MPLAB XIDE with XC8 compiler for writing and building the code, PICSimLab simulator to run and test without hardware. Embedded C is a programming language used to develop software for embedded systems. It is an extension of C language with hardware related capabilities. And in PIC16F877A microcontroller, we also used additional components like buzzer, fan, digital keypad, CLCD, etc. The main objective of this project was to create a realistic washing machine control system using embedded C. It allows the user to choose cycles, monitor water levels, start and stop operations, and display status updates during each phase. The microcontroller runs a program sequence. Keypad inputs let the users choose the cycle. LCD display shows the system status. The system handles the machine's functions in order to fill water, wash, drain, rinse, and spin and finish. So in this code, we use total 12 wash programs. This is the pin diagram of PIC16F877A microcontroller. The PIC16F877A microcontroller controls everything from taking keypad input, managing the wash cycles, turning the fan on for drying, and for updating the display. I wrote the entire logic in embedded C, including condition checks, delays, loops, and input-output operations. This gave me real-world programming experience. So, and this is the block diagram of washing machine system. The washing machine system is controlled by microcontroller that acts as the brain of the system. In the below block diagram, water temperature probe detects the temperature of water. Safety cutout switches ensure safe operations by stopping the process during falls. Wash program selector allows user to select the type of wash. So all these are input devices. And coming to microcontroller, it receives a signal from input devices, executes control logic written in embedded C, sends signals to operate output devices in a time sequence. And output devices are like heater, heats water based on selected program. Water suction pump drains water after washing or rinsing. Indicator displays current status like washing, rinsing, or completed with the help of buzzer. So these are output devices. In the code we have given like switch 5 is used to power on, switch 6 is used to pause or stop, switch 4 is used to navigate, switch 1 is used to check the status of the door. The LCD acts like a digital display on washing machine where it shows instructions, current status, etc. And buzzer is used to indicate stages like completion. Fan is used to simulate the drying process. And I got hands-on microcontroller programming, real-time control logic understanding, and project debugging through this hardware model. These are the tools used. MPLAB XIDE for writing the code, and PICSimLab is like a simulator. These are the different interface screens in the simulator. The first initial one is power on screen. When the system is started, the power on screen appears. It shows a welcome message and indicates that the machine is now ready for the input. Here we declare switch 5 as the initial step. When we press key 5, we will get powering on washing machine message. The next one is washing machine screen. This screen is the main screen of the machine. where we begin selecting the function. It waits for the user input and responds accordingly. And here switch 4 is used to navigate the programs. There are 12 wash programs used in this. They are daily, heavy, dedicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store. All these are washing programs. We can select any of these. So to select those, we can press on switch 4. If we long press on one selected wash program, then it will take to next display. That is water level display. Here the system displays and tracks the water level based on selected program. It fills water to low, medium, high, max and auto levels. The LCD display changes as water fills up and only after reaching the required level, the next process begins. Here also switch 4 is used to navigate to next level or next program. The start and stop screen. The system provides a start and stop feature which the user can control using keypad. If the user presses start, the process begins. If the user is pressed during execution stop, then the system pauses or resets based on the logic. Here we initiated like switch 5 is used to start the program and switch 6 is used to pause or stop the program. Once if we stop the program, or like if we press switch 6, it it will pause if the timer is on, or else it will go back to the initial step. Function screen. In the function screen, the user can choose between wash, rinse, spin and dry functions. Internally, the microcontroller runs specific time delayed sequences to represent each stage, controlling output like buzzer or fan for drying. Once we press switch 5 in the previous step to start the program, then we will get function and timer. Timer will start and according to the timer, function will be changed. If we need to stop the timer in between, we can press on switch 6 to pause and to resume, we can press switch 5. Here switch 1 is pressed to check the status of the door. If we press on switch 1, it is like door is open, so the buzzer will on and in display it will show like door is open, please close the door. Completion status screen. Once all functions complete successfully, a completion screen appears on the LCD. A buzzer sound may be used to indicate that the wash cycles has ended. Throughout the simulation, the output LCD screen continuously updates the current status, whether it's filling water, washing, spinning, or drying. It gives real-time feedback to the user. Once the timer is done in previous step, it will print like program completed, remove the clothes, and again go back to the washing program display. So these are the output displays. The control flow will be like user turns on machine, system checks the door status, user chooses a washing machine program, water is filled to needed level, wash, rinse, and spin cycles run in order. User can press stop at any time. Completion message appears when all cycles are finished. So when we load the code, this is the first display. We need to press key 5. Then powering on washing machine will display and washing programs will come. Key 4 is used to navigate, or else if we need to select on any wash program, if we long press on switch 4, we will get water level display. Again, if we long press any water level on switch using switch 4, we will get start and stop display. This is start and stop display. If we stop here itself, it will go back to washing program display, or else if we start, then it will go to function display. Timer will be on and according to timer function will be changed. If we need to pause the timer, we should press switch 6. To resume it again, we can press switch 5. Once the timer is done, we will get program completed, remove the clothes message. After this, directly it will display back this washing program display. The project includes features like multiple wash programs for different needs, real-time updates on water levels, ability to start or stop at any stage, easy to view programs on LCD. I also faced few challenges like managing time delays between cycles in code, reading keypad inputs in a busy system, showing correct information on LCD at every stage. To solve these, I used timers in code, careful keypad scanning, and tested each screen thoroughly. The project helped me to gain experience in C programming for embedded systems and also learn how to work with microcontrollers and understand hardware simulation with FixinLab to develop system debugging and testing skills. Finally, I built and tested a full washing machine simulator in software. I got hands-on experience with embedded tools and microcontroller programming. This project is a meaningful example of applying high-level programming in real-world systems. So now I will show the demo of the project. Coming to the demo of the project. So this is FixinLab simulator. First we need to load the code using hex file. After loading the code, this is the initial display. Press key 5 to power on washing machine. Here RB0 acts as key 1, RB1 acts as key 2, RB2 acts as key 3, RB3 acts as key 4, RB4 acts as key 5. Now we need to press this key 5. Then we will get powering on washing machine. RB3 is used to navigate the program. So now we will get washing program display. In this program, we use 12 wash programs like daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store. Suppose we need to select daily. Then we will long press on this RB3 by selecting daily, and then we will get water level display like auto, low, medium, high and max. If we need to select auto, we will again long press on this RB3. Then we will get start and stop display. Suppose if we need to stop the code here itself, then we need to press switch 6. Here RB5 acts as switch 6. If we press on this, again it will go back to the washing program display. Now to again continue the program, we should long press on this RB3 and then long press again by selecting auto. Now to start the program, we need to press RB4, that is switch 5. Then the timer gets on and the fan will start rotating. If we need to pause the program, we should press this switch 6. Then the timer will stop and fan will stop rotating. To resume, we should press key 5. Here RB note is used to check the status of the door. If we long press this RB note, we will get door is open, please close the door alert message along with buzzer. This key is used to reset the program. And we use PIC Genius as board and PIC 16F877A as microcontroller. According to the timer, function also will be changed. Once the timer is done, we will get program completed, remove clothes. And then again it will navigate back to the washing program display. So this is the washing machine project. So through this project, I learned how embedded systems are applied in real life appliances. I also gained practical experience in writing embedded C code using simulation tools and understanding how microcontroller controls multiple hardware components. Even though I didn't use physical hardware, using tools like Pixim Lab gave me real-time experience in testing, debugging, and simulating real-world functionalities, which is just as important. And here we use Pick Genius board because it is a training and development board designed for learning and experimenting with PIC microcontrollers. Okay, it also includes commonly used components like LCD display, buzzer, switches, fan or motor driver interface, power supply section, and most commonly pre-mounted PIC microcontroller. It also works well with Pixim Lab, the simulation software we use. So PicGenius board made the development and testing process easier, faster, and safer, especially in a virtual simulation environment. And PIC16F877A microcontroller is used because it is one of the most popular microcontroller for microchip because of its wide availability and low cost. Enough input output pins as in PPT. It is showed that it is showed the pin. I showed the pin diagram of PIC16F877A microcontroller. It has 40 pins. In that 33 input output pins. So we can connect LCD, buzzer, motor, keypad, etc. without shortage of pins. So there are built-in peripherals like ADC, analog to digital converter, timers, USART, which is serial communication, EEPROM for storage, and it also supports with MPLAB XIDE and XC8 compiler, and it's based on hardware architecture and easy to learn, making it great for students for beginners. So since we used all these components, the program worked well. Thank you.